All right, so this is February 2nd. We were looking at doing the first lab this week, but I'm going to just have to push that back because this week just didn't work out. So we'll do lab number 1 next week. So, you know, you already kind of did those calculations for that, and we're just going to wire up the 4 to 20 milliamp signal. And we're going to we're going to do the 0 to 10 on that. And then we'll do Compactlogix IO lab. And I might kind of combine labs 2 and 3. Looking at them, they're very similar. I think if I remember right, I actually haven't looked at it yet this semester, but the Compactlogix, that first one, lab 2, I believe is more of a just a general, you know, the programming piece of it. The ladder logic piece is just, for the most part, I think some practice for you to remember how to use a PLC from PLC1 in part. And then the other part is to actually do it on the Compactlogix, which is a little bit different. We discussed those last week in lecture. And the so I might kind of combine those two and shorten them a little bit so we can kind of get back on schedule, I guess. And we're also going to be, you know, I'll start talking about scaling. Well, I guess looking at the schedule here, right, we've got February 16th as President's Day. So next week we'll do the lab 1, and I might, yeah, and then we'll have that since it's President's Day, we'll have that exam, and then we'll do the Compactlogix IO lab, and I'll kind of put some of that. But I'm going to today, what I thought I would do is just kind of work through an example with you, and some of what we're going to do is just kind of a review of some of the different pieces in the ladder logic, which it doesn't matter whether it's Compactlogix or Compactlogix. Those are all the same. The only difference between the Compactlogix and the Compactlogix is when you're actually adding the modules. And the only big difference, honestly, there is the fact that I guess there's two major differences there. The first difference is the fact that you have a chassis, and your chassis has more slots than you would have on your Compactlogix, and the other is just that you have the, sorry, I had to give my dog her treats here. She had a ball and she couldn't get the treats out of the ball, so I had to give them to her, or she'll be pestering me. But sorry, anyhow, so the Compactlogix, you know, you can have, we talked last time, you can have like 4, 7, 10, I think it was 13 slots or 17 slots for a Compactlogix PLC, where the Compactlogix can't support quite so many. So that was like one difference. And the other difference is actually on the analog cards, they give you some different options. So today I actually, if this works, I actually have a Compactlogix set up, and I plan on doing some setup with you on that, on how to configure them and output some signals and look at those, some analog signals. So to do that, I'm gonna disconnect from the one network right now. And so if I lose you, I'll just log back in here in a minute or two. So stick with me. All right, can you guys still hear me? Okay, please reply again if you can hear me. Okay, thank you, Ted. All right, so the all right, so we yeah, so I should now be able to connect to the PLC that I have hooked up, but I was connected to the VPN at school, and I thought when I disconnected, I was afraid it might log me out of Blackboard, but I think it has not done that yet, or it seems like I'm still in there. So so remember, we have two different software packages that come into play. The first one is the RS Links software. And so, you know, this is Links, is a link or communication program. And so it's just for communications. And so when we use this, what we would do is come up to communications, and then under communications, you would choose configure drivers. And then under drivers, you could add a new type of driver. And so one of the things, if you're using an older style PLC, or even actually the PLCs we have in the classroom, the Contrologix PLC, or the Compactlogix, I believe both of those actually will support the RS-232 serial communication. So to do this, you would have to have a special serial cable that you would plug into your laptop and then plug it, you know, directly into the PLC. So you'd have a laptop or a desktop, and then you would have to have that. So most PCs and laptops nowadays do not have serial ports. And so you actually have to get a USB to serial converter cable to connect up using that. But you can always do that if your PLC has an RS-232 9-pin serial port connection. You can always plug into that and be able to download your programs into it. If your PLC has an Ethernet module attached, which some of them have them built in to the PLC itself now, other ones that you actually need a separate module. But then you would choose the Ethernet devices. And if you have an Ethernet IP network set up, you can choose the Ethernet IP driver. And I did discuss that last week, so what I'm mentioning here is a little bit different. But you can see here I actually have both the Ethernet IP network set up. So if I go to configure here, you have one option is to browse your local subnet. And this is a really cool option here, because what this will do then is you browse your local network, and all the Allen Bradley devices that are on this network using Ethernet/IP. Remember that /IP means industrial protocol. And any devices that are out there on your local network will just show up underneath of this RS Links, underneath of this driver setting. And that's all there is to it. It works really cool. But it has to be on the same subnet. And we talked about that under the networking lecture. I talked about how that subnet mask worked, and that's what this is referring to here. So you have to be on the same subnet. They also have this browse remote subnet option where you could put the IP address, and I guess you would put the IP address of the router for that remote subnet. And I've tried that on the school network to talk to that, and I never quite got it to work, and I'm not quite sure why. It might be because they have the UDP protocol turned off on the router, and they don't allow that type of communication or something along that sort. But it did not work for our network at the school, so that doesn't work. And the problem with the classroom is our PCs, our desktop PCs in the classroom are on a different subnet than those blue switches on the desk that we're going to plug in our PLCs to. And so the local subnet piece doesn't work because we're not on the same network. Our PCs are on a different network. So the browse remote subnet, that should work, but like I say, I think it's a UDP protocol that uses, and so it can't talk to, I think they have that shut off on the router. So we would have to get the IT department to reconfigure the routers for that. And I think they have them shut off for security reasons. So they're probably not willing to do that. All right. But if we had the protocols working, this would be cool, because you could see everything plugged in on the network. And so the Ethernet IP driver, if it works for you, it's very nice. All right. But like I say, in our classroom, we don't have it. It doesn't work. So when you add a new driver, you can actually, if you know the IPs of all your different devices, you can just put them all in there. So you see, I actually have all our PLCs, or at least most of them here, that we have, and so I just have them in here. So now once we configure that driver, we can come over here and we can hit the plus sign, and then we can see all those PLCs. And so right now you see the big X on them all, and that's because it's connected from the subnet, so I can't talk to any, or the fact that they're just not turned on. Okay, but in my case right now, I'm not connected to the school network anymore, and all those IPs are the school network IPs, and so I just can't talk to them. And but I do have this one PLC here, which has the IP address. You can see the IP address right now. You can see the IP address right here is 192.168.2.4. You can see that this is an L24ER QB1B Logix, which is a Compactlogix. You can see we talked a little bit in the other lecture. 1769 tells us it's a Compactlogix bus, as opposed to the Control-Logix bus, which is 1756. So the 1769 actually tells us which bus it is. And then actually down here, it tells us it's a compact bus. Okay. And then we have the PLC, which is module 0, which is kind of all one box, the main box there. And then we have embedded discrete IO, which is module 1. Okay, and that one's embedded, so we don't have to add that because it's already embedded. And then we have a second module, which is an external module plugged into it. So it's an extra module that you have to buy, and this one is a 16-point AC/DC relay. And then the third module, which is the second external module that we have plugged in, is a 1769 4-channel input, 2-channel output fast analog card. All right. So those are what we actually have attached in this Compactlogix PLC, an L24ER-QB1B PLC. All right, and this is actually a slightly newer model than the ones that we will be using in the classroom. And so, but the modules, these two extra modules that we added are the exact same modules that we have in the classroom, because it's a 1769 bus. So the modules work, the exact same modules work because they work with the PLC that you could plug into that bus. All right, so given that now, I'm going to open up the RSLogix 5000 software. And remember that the RSLogix 5000 software is the programming software. So the RSLinx is the communication software, and the RSLogix 5000 software is the programming software. So now when we come into this software, a lot of times, like, it'll give you, you know, if you've already had something loaded up, it will give you, you know, these are the most recent files that you have had opened up. And so you can just recall one of those programs that you have saved onto your hard drive or flash drive or wherever you've saved it. You know, it would remember, hey, you had this open recently. All right, and so you could call that up. All right. So the, but, you know, for us in the classroom, we're usually just going to be starting with brand new programs each time. And so we just come in and we can come up to the new. So we can either just say file new or control N to create a new one, or hit the little icon for new, you know, whichever you prefer. And then you will see it pop up the new controller window. And so in the new controller window, you have to select your controller. And actually, it's come up right now to the 1769 L23E QB1, which is the one that the Compactlogix version we actually have in the classroom. All right, so that's the one we actually have in the classroom we'll be using. And then you have to choose which revision number. And you see here 16 is grayed out. I can't choose 16 because 16 is not a valid revision for the L23 Compactlogix. So when revision 16 was out, those PLCs hadn't even been built and sold by Allen Bradley yet. All right, and so but what you have to know is what the revision number of the PLC is. All right, so here you get to make a choice which one, but the choice is very important. It's only going to work if you choose the correct version. And so again, we can come over here and we can come down to a right click over here and say, you know, give me module configuration, and we can see right here we are on revision 20, right? So if you don't know, just go to RSLinx and look at it, and you can see that, yes, this is revision 20. So I don't want to choose revision 19. It's not going to work. Okay? I need to make sure I choose revision 20. And that different software version will actually change a few things. Most of the stuff it's not going to change. A timer is still a timer. The biggest thing it changes is settings and options for I/O modules. That's really the biggest change. You know, but you know, normally open, normally closed contacts, relay output things that we would put in ladder logic and that kind of stuff doesn't matter. It's just it's more of a module configurations and some other configurations. There may be a few extra blocks that we could add to the RSLogix or something like that, but for the most part, the biggest thing is just the I/O. And so, but anyhow, so now, oops, I hit the escape button and it disappeared. I got cables were in the way and I was trying to move them and bump the escape. So I'll start again, new. All right, so what we have to do is choose the one that we're going to use, and the one that I can talk to right now is the 1769 L24ER. And so I'm going to click on this down arrow over here on the right of the controller type and go down to L24 ER QB1B. All right, and again, we see that right here, 1769 L24 ER QB1B. So I just select that one, and version 20, okay, which you can see that 19 was no longer an option there because it didn't actually work with the controller that I have. Okay, so in this case, it knows that this is the L24, and so version 19 was not an option for this PLC. And then we come in here and we can give it a name. I'm actually going to call it Akron PLC because these are the ones that we actually have in the Akron lab. And call it AnalogIO. So a couple of things about this name. This name here, you can put numbers and letters in it. I really don't recommend spaces in here. And you probably don't want to make it overly long, okay? But then you have the description here, so you can put in a lot more information in the description. And then for where you're going to create it, well, you can do a browse. And under browse, then you can choose where you want to save your files. They default to C:/RS-Logix 5000 projects. You don't want to save it here on the C drive because if you're in the classroom, remember the C drive gets erased at midnight, or if you just have to reboot right there in the middle of lab, if you know your PC was to lock up and you had to reboot or something like that, it would be gone. All right, and because of the settings and software that they have installed on the PC, so you need to put it somewhere, either on the D drive in the classroom, or you can put it in the on a flash drive or something like that. But don't put it on the C drive. You may lose it in there, even if you want it. So I'm going to just put it here in C25 user. I guess for my case, for this lab here, I'll just put it there. And we don't need any security settings for what we're going to be doing in the classroom here, so we won't mess with that. And just say OK. And again, it may take a few seconds because it's kind of looking at all the different options and things that are available there, so that we put those in there and see what's available. All right, so now you know, you can come down here under IO configuration. Okay, so I kind of think about this software as being kind of like a murder mystery, right? When you read a murder mystery, you always have to go to the end of the book and find out who done it. So the first thing you do is read the book, read the last chapter, and find out, you know, who did it. And that's kind of the way I think of this software here, because you really have to come down here and define all your I/O that you're going to need. All right, so we do have the embedded I/O, so we don't have to add that, but our expansion I/O, which over here are modules 2 and 3. Okay, so for these PLCs, you can tell, right, module 1 is embedded, so it's there. Don't worry about that. But module 2 is a 16-point relay module, and module 3 is the 4-channel analog I/O module. All right, so we need to add those. And so we'll come over here so I can see both screens at the same time. I'm going to come over to Expansion IO, right click, and add a new module. And so it pops up the module here. And the way this works, and again, it depends on which version you selected, but the way it works is it shows you, right now it's showing me pretty much every module that I could imaginably conceive. So what we can do here is we can say, you know what, I'm looking for a relay module. All right, and so you can just type in relay module, and now you see that out of all those options, I've got 4 to choose from. So instead of me having to scroll up and down trying to figure out which one it is and trying to read all this, right, I'm looking over here and I see that module 2 is relay. So if I just type in relay, it immediately drops it down to 4 choices. And then we can read, again, come back over here and read, and we see, oh, it's 16. There's 16 relays. I only have 1 to choose from. It must be the OW16. All right? So, you can tell that very, very quickly simply by doing that. And then we just click on Create, and it will create that module. We give it a name. This is our relay module, okay? And if you actually had multiple relay modules, you may want to name it like relay module slot 2, okay, or something like that, or at least put it in the description which slot it's in. If you only have 1, it doesn't matter. The other thing is now it wants to know what revision, okay? So we can come over here, we can right click and look at device properties, and we can see that it's revision 3 sub 1. So major revision 3, minor revision 1. And so if I click on this, you can see it's defaulting to revision 1. I want to go to revision 3, and then you can also select sub revisions, okay? And then they have what they call electronic keying. All right, and if your revisions match, then you could probably go with compatible modules. If you're having an issue, you could select disable keying. So, because sometimes the keying messes it up or something. And so, but with the Contrologix, I've had a lot of issues with that. If things don't match up perfectly, it might be an issue. But for the so if you're having a problem, you may want to try disable keying there. And you can't really select, it's just integer output because it's just sending out 16 ones and zeros to that card, right? It's a 16-point thing, and you're just outputting basically a number every time. But each one of those bits would turn on a relay. So it's an output device. There's no input. All right, so I changed those and selected those, and now I'll say OK. Now it's like, well, we've added that module. So if you look down here, right, you can see right here, there's the module I added. And so now I'm coming up here, I'm going to delete relay. Now I want to put in fast analog. Okay, and actually I haven't even finished typing. If I type in fast, I only have 1 choice, okay? And so you can see here's my 4-channel in, 2-channel out, fast analog, and that's it. So by using this filter option up here, I can go from 60 down to 4 or even 1 very quickly if I can type. Okay? And so we're going to select this. This is going to be our analog card. And that part number, you can also get that part number off of the door of the module. So if you flip open the door, you'll actually see that written at the bottom of the module there. And this is just going to be my analog card, and it's going to be in slot 3. Now notice you can change the slots, but if you put them in the order that they are, when you start adding them in here, So if I would have added analog first, I would have had to select 3 because it would have tried to put it in 2. Right? And so again, we do have our revision number here. So you come back over here to the RS links. Now notice with the relay module, it actually told you right there it was revision 3.1, but the fast analog isn't telling me that. So I must go to device, and I see that that's major revision 1, minor revision 2. So I'm going to close that out there. And I'm going to come over here, major revision 1, but minor revision 2. And that's interesting. Connection is an output, although it's also an input device. And so I'm going to add this module, and I'm going to close this window now because those are all the modules that I have to add. And so there's my 2 added modules. And so now I am ready to create some programs. Okay. So when we create programs, we need some tags. And if you look here, there's way up here at the top, we have the controller. All right, so this is our controller. Now let's say that you accidentally selected the wrong controller. If you right-click on this or double-click on it, it will pop up a little module, and you have your change controller here. So you can change if your version's wrong, or if you, if your whole controller is wrong or whatever, you can actually still change that. All right, so it's not the end of the world if you selected the wrong one at the beginning. You can make changes. Also, if your controller is faulting out for some reason, you would come here and come over to the major faults tab or the minor faults tab and see what faults it's generating, and then you'll have a choice to clear them if you actually have some faults showing. Usually the faults show up in our classroom, especially. The biggest time I see faults is because you either selected the wrong I/O module, or you got the right module, but you've got the wrong slot selected, one of those 2. You can also come in here and view port information or networking information. All right. If you needed to but to change the IP address, you could do that over here in the RS Link software. If I do a right click on this and I go to module configuration, this is where I could actually come in and change my IP settings. So we have our IP address, we have that subnet mask that I talked about, and then we have a gateway, and we have a DNS name server. And so you can set those, or change those if you need to. Okay, please don't be changing the IPs on our classroom PCs. That will mess us up. Okay, but if you're using your own PLC and you need to change an IP, you can certainly do that there. Okay, and if you're actually online, you could actually do that up here also. That's like this internet information. You could actually change that if you were online with the PLC. All right, so to create a ladder logic program, right, we will come to tasks, main task, main program. Now under main program, there's program tags and then our routines. And later on, we'll be looking at how we could actually add multiple routines in here. Okay, or we could actually add different programs to run. All right, now I want to point out to you here, there's something called controller tags and then program tags. Program tags are only seen by the program under this main program. So if I actually right click on this under task, I can create a new program. If I create a new program, this new program will not see program tags from the main program. Right? But controller tags will be seen from any and all programs that you create. So these are what we call a global scope okay, is kind of another term that's sometimes used. A global scope, all programs that you may create will be seen by tags created in the controller tags. So I recommend that you don't create a lot of controller tags. You can create a few. Your IO tags should probably actually be controller tags, but any like virtual tags, any tags that you create for storing information, numbers, calculations that maybe you're doing inside of your routine should be under program tags. They should not be under controller tags. Controller tags should only have tags that you want to be seen by all programs, or maybe from that you're going to share with outside devices across the network. And so tags that you want to share across the network, then you might want to put those under controller tags. But so I see a lot of times that people just want to go to controller tags and put them all there. And what happens is you end up getting a lot of tags, and it gets actually more confusing there. So you want to be careful. I recommend, for the most part, just go to program tags and put everything in program tags. Okay, and then later on, if you decide that, hey, you know, that you need to see this from an outside device, then maybe that particular tag should be moved into the controller tag. But in general, do we want to just go to the normal tags here, and we can, under tags, the first thing it does is go to monitor tags, but we have to create those tags first. So I'm going to come over here and I'm going to create like an channel 1 or channel 0. So I'm going to say output channel 0. Let's see, output channel 0 current. Okay, so I'm going to output a 4 to 20 milliamp current here. Okay, now when you're doing tags should never have spaces. They can have uppercase or lowercase characters. They can have numbers, and they can have underscores, but they should not have any other character in them. So be very careful when you're creating tags. Don't put spaces in them. Do not put like minus signs. You know, it won't even let me try to put a minus sign there. All right, so but this is going to be a current output, and this is going to actually be channel 0 output. So it's going to be an analog card, which is module 3, and it's an output. Now when you select this, now I'm O for output, and notice here, remember, we only have 2 outputs. So we have channel 0 data, which is an integer, and channel 1 data. Now notice these are integers. That means that they are 16 bits. Those are words. Integers are also known as words. They're 16 bits. Notice you don't click on this and choose 1 bit. It's a number. You have to choose all of it. It needs to be a 16-bit number. Okay, I might even write that down here in the description. This is a 16-bit integer, meaning there's no decimal points. Okay, so it's a 16-bit number. And then we have this one here, or let's see, that is my output to channel 0. And then I'm also going to create an output to channel 1, which is a voltage. Okay, and so remember that when we talked about analog signals, you can have a current signal out, or you can have a voltage signal out. And so that's what this is. I'm labeling these here The channel 0 is going to be a current out. So it'll be a 4 to 20 milliamp current. Channel 1 is a voltage. Okay, now remember I have 2 channels, but I do not have a channel 2. I have a channel 0, which is my first channel, and I have a channel 1, which is the second channel. There is no channel 2 because I only have 2 output channels. All right, now the alias column. Remember that an alias, the alias means that this is a physical wired output. Okay, so what we're doing here is if you have an alias, it means that you're actually physically wiring this thing out somewhere. So it's a physical real output as opposed to something stored in memory. All right, so if you remember, like we had our virtual relays that we talked about in PLC1, we had virtual relays. Okay, these are binary values, but they're not wired. Okay, so they're Boolean because it's a single bit. I shouldn't have an S there, it's just one relay. So we have this virtual relay is 1 bit. So it's a Boolean, but if it's virtual, it means it's just being stored within the memory inside of the PLC, and it has no real-world physical sort of connection or interaction. And so therefore, we just put in here virtual relay. Well, I mean, I put in virtual there, but under the alias, nothing goes under the alias because it's not a physical wiring. And so I can also, I'm just going to create a virtual start, which is going to be, of course, a Boolean. And the reason I'm doing that is because I don't have any buttons wired up to my PLC today. So I'm going to have a virtual start, and I'm going to have a virtual stop. Okay, and that's going to be a Boolean. And I need some timers. I'm going to use a couple of timers here. So I'm just going to, in this case, I'm just going to label them timer 1, which I guess I'm going to call tick, because what I'm going to do is I want to have 2 timers to kind of go back and forth. It's like tick tock, kind of like a clock sort of thing, so that I can advance a counter automatically. Okay, so I'm going to have timer 1, which again, it's a built-in device, so I don't have any alias for that, but when we come to data type, this is going to be a timer. So now notice here you see the ... this little ellipse sort of thing. If I click on that, this allows me to scroll up and down through every possible option. All right, and so there's lots and lots and lots and lots of these. Okay, you don't have to scroll down. That's the slow way of doing it. If you want a timer, come over here and type in TI, and it immediately says, oh, you want a timer, and then just hit enter. All right, so if you want to do it the slow way, you can come over here and click on this and scroll and scroll and scroll until you find a timer. Okay, but if you know you want a timer, just type in TI. You don't have to type the whole word, just TI, and boom, you're there. So I'm going to create a second timer, which I'm going to call talk. And again, TI, boom, there's my timer. I'm going to use a counter. Counter 1. And COU gives me a counter. So I had to type COU to get to a counter there. All right. So there's just a few devices that I kind of put in there. And so I have an output that's going to be a current output. I have an output that's going to be a voltage output. And then I have these devices here. And what I'm going to do, I wired channel 0 output into channel 0 input. And hopefully I've got them wired correctly. I didn't test them yet because I was in a hurry to get it done before class here. So I hope I wired them correctly. We'll find out here in a bit. But what I plan on doing is I'm going to output a output number. I'm going to output a number to my output current, and I'm going to output a number to my voltage, and then we're going to read those in and see what those are. So we're going to have an input. So I'm going to have input voltage, and when we go to the configuration, I haven't actually configured my analog card yet. When we go to configure that, we can configure it in different ways. Okay, so we're going to have an input voltage and an input current. Okay, so it's going to be channel 0. Channel 0 is going to be an input. And input channel 0. And let me flip down to see the choices here, because what I want to do is like show you all the different options here. All right, so we're going to have input configuration. So I'm going to enable channel 0 input and channel 2 input. Remember, we have 4 inputs and we have 2 outputs. So I'm going to enable the 2 outputs. Now the output here, on the output, what I'm going to do is I'm going to say, give me 0 to 20 milliamps for the output for channel 0. Because remember, I've already mentioned that channel 0 is going to be a where was it? Channel 0 is going to be a current. Okay, so, and I'm going to go ahead. I could actually choose. Yeah, let me go ahead. I'm going to choose the output to be a 4 to 20. Okay, so the output is going to be a current, so it's going to be 4 to 20. And then it says engineering units. Okay, so the engineering units here, we're going to look at these. These are one of the things that I plan on kind of illustrating to you today, what the difference are. So we have something called raw or proportional. We have engineering units. And then we have a scaling for PIDs, which we're not really going to use until, we probably won't use in this class anyhow, but we will talk about PID controllers. But this is some special option if you're sending an output for a PID controller. And then there's a percent range. And you know what? I'm gonna set this to percent range, actually. Let me, for the output, I'm going to set them to percent ranges. And for the voltage one, we have we got 4 different voltage choices. We have -10 to +10, or 0 to 10, or 1 to 5, or 0 to 5. I'm going to select the 0 to 10 volts. Okay, so I'm going to select that output, and but on the input here, we're going to look at raw or proportional values. And what we're going to do is we're going to look at raw, proportional, engineering, or percent for the inputs. Okay, but remember that this input is current. Now on the input, technically on the output, I selected 4 to 20. However, the inputs, I'd like to, and you can change this later or whatever, but for right now, I'm going to allow it to go all the way from 0 to 20 milliamps. All right. And so the input range is 0 to 20 milliamps, and we may flip that a little bit later to look at. The other option here is filtering, okay, and they default to 60 hertz filtering. And what this does is try to apply just a little bit of filtering. You may remember filtering from AC circuits class or something, but it tries to filter out some noise. And I actually prefer the 5 hertz setting most of the time. And this is something you have to kind of analyze your input signal. And if you have a noisy input signal, 5 hertz usually is the best choice there. And so I'm going to choose filtering of 5 hertz for both channels. And the again, we're going to keep them raw and proportional for right now. But we're going to come back once, if I got these wired correctly, we'll see. We're going to come back and we're going to see those change a little bit there. All right, and so we have our outputs here, which is just a percentage. Now, the thing is, a percentage, what they do, they don't go from 0 to 100% because it's an integer value, and they want to give you more options. So what the percentage range is actually going to be is it goes from 0 to 10,000. So what they do is they basically give you 2 more decimal points for more accuracy. And so the percentage range is going to be from 0 to 10,000 is the range. And you'll see that when I flip over here and I go to percent range. Okay, so this is just going to be like 0 to 10. So what I'm going to do here, now I've enabled these, and we'll come back and look at these once we get some ladder logic working. Okay. But see, it doesn't like that, okay, because I forgot the output limits. So when you choose output configuration, you see that this is going to go from 4 to 20 milliamps. And so I need to come over here and say, well, it can be 0, and the high is going to be 20,000. All right, now notice the 1,000 here. What this is doing again is like I mentioned with the percentage, or wait, I'm sorry, this was percentage. Yeah, this was percentage. So actually my high is going to be simply 10,000. And so that is my thing. And then if you see here, we can actually latch alarms, and we can set up alarms for these. Actually, for output, I don't know why they, we need a tag to do that, I guess. But, you know, so input alarms, if your voltage is too high or too low or something, you could have it set alarm bits. And then we could add ladder logic to, you know, turn lights on or whatever if we reach those alarms. But you do have to come in here and you have to configure it. So in this case, I'm putting an output, which is going to be a percentage. So 10,000 is really 100.00%, but it won't let me put in a decimal point. Okay. So because it's just an integer output, so there's no decimal point. So but they give me 2 extra zeros for accuracy. So it's going to be 0 to 10,000. So depending on which type of output you choose, you have to set the appropriate clamp here to prevent it from going above or below those values. All right, so I had to set those. Now I should be able to say okay, and now it will close. So now I'm going to come over to the main routine. I'm going to go ahead, come over here to my favorites, and I'm going to drop down my start, which I had or stop. I had a virtual stop. and then I have a virtual start, and then I need a branch, so I'll pop a branch in here, drag this over. Okay, so you notice you click on the start and you can drag this over. One thing I want to remember, if you wanted an examine if open, you can actually click on that right there and change and make it, you know, the normally closed or examine on open option, or examine if examine if closed. Sorry, examine if closed. And you can change those. So if you drug the wrong one down or you decide you need to flip your logic, you can change it later. Okay. And so notice here when you're dragging one of these around, the little green dots will show up where you're allowed to put it. Okay. And you just drag it around, and then you can click on this and change it to whatever that you want here. And then since the virtual relay is an output, it automatically throws it over there to the outside. All right, and then if we come over here, Control R will give us a new rung, or we can right click and add a rung. And so now I'm going to have my virtual relay, okay? And this is going to be my timer 1. So I'm going to come over here and I'm going to have a timer 1. Okay. And that's going to be a tick. Or, you know, I named that timer 1 tick. And I'm going to make that, I guess I'll make that about half a second. We might change that again. Remember that timers on Compactlogix have a time base of milliseconds. So 500 milliseconds is 1/2 of a second. And then the accumulator will start out at 0. So you don't want to change that. Now, I want to copy this entire thing here. So I'm going to do a Control-C, Control-V over here on the numbers, and that will paste this. And now I'm going to change this. This one is going to be timer 1 underscore timer 1 underscore tick dot done. So this is going to be the done bit. So when timer 1 has reached 500 milliseconds, it's going to turn on its done bit, and that's going to turn on 2. So this one here now is going to be timer 2, which is my talk, and that's also going to be 500. So I don't have to change that. And then now I've already pasted this first rung and pasted it. I'm going to come click on the end, and I'm going to type Control-V and paste it again. All right, I didn't have to. I could just create a new one and drag and drop if you want. But so now what I'm going to say is when timer 2 is done, so when timer 2 is done, what I'm going to do is I want to advance my counter. Okay, so I'm going to come over here and I'm going to have a count up. So I have a count up. So notice here it was T on, right? It was T on for a non-delayed timer. And if I click right there on those words, I can actually type in some other choice. Okay, so I want a count up option, and so that is CTU. All right, now if you don't know what they are, you know, you can always just come up here, find the counter, and you can actually see it right there. It tells you. All right, or you could just drag it and drop it down there, but if you want. But you know, if you know what they are, you can actually get to them a little bit faster. But now to look, I don't want to forget that this should just be counter 1 here. And the preset, what I'm going to do is set this to be a preset of 100%. All right, and the accumulator should just start at 0. And then I'm going to paste this rung again, but this is going to be counter 1 dot done. And when counter 1 dot done is done, I want to reset, and I want to reset my counter 1. Now on top of that, up here, when timer 2 is done, I need to reset my timer 1. So I'm going to advance my counter, but I also need to reset my tick-tock timer count here. So I'm going to come up here and add a branch and drag this over, and then you know, again, you can come up here and just click on your reset, and this is going to be timer 1 reset. All right, now remember that timer 2 is anytime rung 2 goes false, will reset a timer on. And so it's automatically going to reset timer 2 when timer 1 is no longer done. So once I reset timer 1, that will automatically reset timer 2. So I don't need a timer 2 reset. Now, the next thing though I want to do is I want to output this 0 to 100. Okay, so remember that I'm outputting a percentage. So I'm going to output 0 to 100, but it needs to be multiplied by another 100, so it can be 10,000 at 100%. And so I'm going to add my rung again. Well, in this case, I just did a Control R and added a brand new rung. And what I'm going to do is move this output. So when counter 1 is done, I'm going to do a move. So I think I'm going to actually just add this as a branch. Okay, so what I'm going to do is at the bottom of my branch, I'm going to put the counter reset. And on the top of my branch, I'm going to do a move. So I'm going to do a move here, and I'm going to move, or actually, I'm sorry, I don't want to do a move, I want to do a multiply. So if we go to math, we want multiply, M-U-L. And again, we could just click there and type it if we know what we want. And sometimes like multiply, you can just practically guess that. So what I'm going to do is I'm going to take my counter accumulator value, my .acc, and I'm going to multiply that times 100. And the destination now, I'm going to output that, and the destination is going to be my output channel 0 current output. And now I want another branch. Now watch what happens. If I come over here and select this branch, it makes like a sub branch. And I really don't like that. Okay. But if I select this one here, it keeps it the same size. And I like the my reset counter to be at the very bottom. But I'm going to copy this multiplier and put it here. And this is going to be my output to my voltage output. All right, so we're going to just kind of look at this and see what happens now. So I'm going to pop this to full screen, and I'm going to download this to my PLC. So remember, I haven't talked to my PLC from the 5000 software yet. So I got to tell it who to talk to. So we come over here to the Who Active. And it pops up the screen, and I'm looking for the screen, and it actually popped up on my second monitor. So I had to look over at my second monitor to see it. So it was there, I just wasn't seeing it, and I was, so we can come here and we can select our different PLCs. Now the PLC that I'm talking to is this one here. So remember, you have to select, like if I select right here, for this model of PLC, that's all I needed to do. Sometimes you have to drill down all the way into the bus and then select the actual module number. It depends. If it's grayed out, then you don't have the right one selected. So you got to make sure you select the actual PLC. Okay. For this one here, I can actually select it right here, and I can download it. Okay. Now remember, download is going to take your program from your PC or your laptop and go down to the PLC. Okay. So you have to kind of look at it. Sometimes it's confusing whether you're downloading or uploading. So in this case, we want to take our program that we just created and send it to the PLC. So in this software, that's considered a download. So we just tell it to download that. And now it's downloaded, but notice it's not running, right? We don't see any green here. Our timers aren't moving. Nothing's happening. The reason for that is up here, you see that it's in remote program mode. It's not in run mode. So now we have to come over here, click on this little cyan box over here, and come down here and say go to run mode, say yes. And now this is green, it's running. But my program's not doing anything, but you can see the green bars are showing up here, right? And so that at least tells us that we are in run mode and we are online. All right, so now what we have to do is we have to push the start button to start this. But remember, this is a start button. So I don't actually have a real button wired up to this PLC, so I couldn't put in a real button input. So what I'm going to do here is if I just come right over here, I can either right click and toggle the bit, or they tell you right here you can just type Control T. So if I just hold down my control button and press T, that turns my start on. All right, but the stop isn't on either because it's virtual, so I need to turn that one on. So I turn those both on, and now it's sealed in, and now we can see the timer counting, and as the timer counts up, it's outputting values. But it's not multiplying it. It should be outputting a value here, and it is not. Okay, so let me look at this and see what's going on here. So I'm taking 38 multiplied times 100, or 43, or whatever the number is, right? So I should have 4,700 here. And I've got nothing. So I'm going to go to output. Output channel 0. I wonder if I got my wiring shorted. Output channel 0. Thought I enabled my output, right? Enabled. Should be a current. Those are both. Okay, so let me look at my tags and see if I can tell anything better here. So these guys are at 10,000. Okay. Output channel 1 voltage. Did I not? Okay, so let me go offline here a minute. I forgot as I was talking, I need to make this. Should be local colon 3 colon O for output channel 1 data. Okay, so I was missing the alias there for my actual output. All right, and so outputting my values, and I wanted to look at the input channel 0, so I forgot to actually add that one also. So that should be local 0 or local colon 3 colon I for input dot channel 0 dot data. That should be my input. Now what I've found here is if you're doing a lot of these, you can copy them and paste them and just change the numbers. Okay, and so this is going to be input channel 1. All right, and I've enabled both of those. And so okay, so if we set our alarms, just want to see. Let's see, that was 0. I'm just going to make that 500 now for an alarm just to see. Okay, so now now I'm going to re-download this because I forgot to put the aliases for my input and output channels, except for the first one there. So I'm going to come over here. Now we don't have to come over here anymore and choose. It's a little faster if you just come over here to this box and click on download. Okay, so it's a little bit cleaner and faster if you do that. You still got to okay it. All right, now since it knew I was already in run mode, it's going to ask me if I want to switch back. Okay, and so before I was already in program mode, so it just didn't ask. All right, so now I need to enable these. Okay, so they're enabled. My timers are counting. My accumulators, and I'm outputting voltages. So I'm multiplying 12 times 100. Okay, and so if we come over here and we look, okay, it doesn't look like it's outputting my values yet. But look at the input channel. Okay, the input channel is changing. So I'm not 100% sure why this output is not changing, but we definitely see that these values are changing. And so we see that this one is minus 20,000. Okay, now this was actually a current. This is a current input. But remember that we're currently using it as raw input. The configuration of this was raw. Okay. And this one was a voltage, and it's a raw input also. But what I want to point out to you, when we look at our configuration, this voltage was minus 10 to plus 10, but this output is only 0 to 10. And so if I change this to be 0 to 10 also, and I go back and look at my program tags, notice, okay, I'm not 100% sure. Well, I'm going to try a couple things here. But notice that I'm not getting anything between 0 and 10,000 up here. And so now that I'm at 10,000, these things are positive 30,000 and positive 29.7. Okay, so those things are positive. Just not quite sure why the multiplier, this multiplier doesn't really seem to be doing anything. Oh, it's only doing it during the counter done. That's why. I'm sorry. That was my bad. I need to do this all the time. Okay. Sorry about that. That's why it wasn't doing it all the time, because I told it not to do it all the time, which is generally what happens. So I'm going to go offline. I'm just going to delete this contact so that I'm all the time outputting every scan. I'm going to take the accumulator value, whatever it is, and output it. Okay, I was thinking that I was going to do it on counter up, but I'm just going to output it every single scan. So notice here we have no contacts on the left side. So I'm just going to output every single scan 100, or whatever the accumulator value is, times 100, and output that to my output channel. Okay, that was my problem. I was only doing it when the counter was done. That's why it was never changing. All right, so now we're back in run mode. I'm going to enable this using my Control T to force the value. And so we can see the timer going here, and we can see it resetting and everything. And now if I come over to my tags, it's still not changing. Okay, so I want you to notice that this is minus 20,000, okay, and minus 29,000. And when it gets done, it'll go to 10,000 and output that. So I'm going to try something here. I'm not sure about the whole multiplier. So I'm going to just come over here, and I'm just going to do a move. Okay, so I'm just going to move my counter. I'm just going to move my counter into my output. Okay, and so I'm going to do that here. So again, I can just change this on the fly. And then this is still my accumulator value, but I'm going to output it to both channels. All right, so what I'm going to do is I'm going to change the counter down to 50 to make it run a lot faster, because it's got to go all the way up to 10,000 now. So I'm also going to change my counter value up to 10,000, which is 100.00%. And now I'm going to download this and see how it goes. All right, so what I'm doing again is I'm feeding a current output, which is going to be some value between 0 and 10,000, where 10,000 is 100%, 100.00%. And we're going to feed those in. Okay, so you see this thing's really not advancing my counter now. What's going on there? Timer 1 is done. Go offline. All right, so I'm going to put a branch here and say when, no, don't want to do that. All right, so when timer 2 is done, it should advance counter 1. And it's not moving. All right, before I do that, I'm tired of toggling these things, so I'm going to come in here to monitor tags, and I'm going to put a 1 for both the start and the stop. Okay, so if you set the values before you download, it'll keep those values. Okay, and so now I'm going to re-download this, and so as soon as I download, it's actually just going to automatically start. All right, so again, we see these values here. This is 29,000 and 20,000. Okay, but my output values are not changing. I'm not sure why these moves are not quite working. Those are outputs. That should be valid. And oh, my counter is not moving now. Why is my counter not moving? It should be. Counter 1 is being reset. Oh, that's my problem. Remember, okay, sorry about that. I see it right here now. So remember before I had here, got to go offline. All right, so down here I had a counter 1 .done tag, and now I removed that. So what happens is it keeps resetting my timer, or my counter, excuse me. So resets, you got to be careful with your resets. It's really easy to mess up there. So what I'm going to do is when counter 1 is done, then I'm going to automatically reset it. Okay, so sorry about that. Little debugging for you there. So that's what was happening, because now I was doing it every scan. I was resetting counter 1. So guess what? It was going back to 0 before I actually ever output anything. So let's try this one more time here. And again, I've already forced my virtual start and stop to 1s. So as soon as I say yes here, it will start going. They will start counting. And when we do this now, we can see that my accumulator values are going up. And so if we come over and monitor our tags, you can see that these values are changing. All right. So these are the counter values. So the counter is going up, right? Remember, it's counting up pretty fast now. The timers are every 50 milliseconds. So every 100 milliseconds, or 10 times a second, it's advancing the counter. So I've got it advancing the counter pretty quick. And we're already up to 300, 400. Now notice here, if you click on one of these, you don't see it change. It is still changing, you just don't see it change. All right, so when we look at this though, we see these values. Now remember, these values are raw values, and so they're going different values. So let me try to, I'm going to pop open Notepad here. Yeah, thank you. You caught that, but I didn't look at the chat window. So Uh, yeah, you're correct. I should have looked at the chat window faster. Sorry about that. All right, so yeah, so what was happening, as you pointed out there in the chat window, I had my reset always true. Okay, so you caught it. Very good job. If I would have looked at my chat window, it would have been a little bit faster there. All right, so anyhow, I'm going to open up Notepad so I can kind of walk you through values here. Okay. And this goes back to the analog signals that we were talking about before. So all right, so for channel 0 output, okay, channel 0 output is going to output 4 milliamps to 20 milliamps. It's supposed to be like an arrow. So that is the range for the channel 0 output. However, I'm sending it out as a percentage. Okay, so this is a percentage. And so the percentage is 0.00 to 100.00%. But we can't, these are integer values. You see right up here, it's labeled integers. These are labeled integers. I can't have any decimal points. And so therefore, what they're doing is they're multiplying this times 100 to give us some decimal point accuracy. And so the actual value is going from 0 to 10,000. Okay, so what that means is that 0 is 4 milliamps. And 10,000 is outputting 20 milliamps. Okay. So what that means is that if we are at, say, like right now, it's almost 2,500. Okay, so 2,500 is going to be 1/4 of the way. Okay, so 2,500 would actually be 1/4 of the way. So that, that's going to be 8 milliamp. So that's actually going to be 8 milliamps. So let's look at channel 0 input. Channel 0 input, okay, right now is set for raw. Okay, so channel 0 input is set for raw. It's a signed integer. And so what happens is the smallest value, there is going to be minus, officially it's actually minus 32,000. Okay, so remember it's signed, so the most significant bit is the sign bit. So the most significant bit is the sign bit, and then you have 15 bits left over. All right, and so what it's doing is it's actually running from, we have 15 bits, which gives us let me pull out my scientific calculator here. So we have 2 to the 15th power, which gives us 32,768. So what's going to happen here is our values are going to range from a minus 32,000 768, okay, all the way up to -1, 0, all the way up to a positive 32,765, because there's actually 536 possibilities, which is 2 to the 16th. Okay, 2 to the 16th is 65,536 possibilities. But because the sign bit, because it's display sign bit, if this is a 1, it shows as a negative sign. And so the number actually runs from 32,768 to -1, then 0, then from 1 to 32,765. All right. And so for current, okay, so for current, and remember, we're reading in from 0 to 20 milliamps. So even though we're outputting 4 milliamps, we're reading in to 20, we're reading in 0 milliamps. And so what that means is that when this was 0, when this here was 0, when the current was 4 milliamps. So 4 milliamps actually shows up to be about -20,000. Okay, so 4 milliamps actually shows up to be about -20,000. Now look, right now we're at halfway. Right there, we're at 5,000. We're at halfway. Let me pause. Well, let me just look at this. So the input channel is 5,000, and the output is almost 0. See, the output is almost 0. Or excuse me, the input channel voltage is almost 0. And the reason for that is because if you're halfway, okay, your halfway mark, okay, your halfway mark would be 0, right? 0 here is the middle. Okay, and so when we were doing the voltage, right, we're outputting a 0. For the voltage, we're outputting the voltage somewhere between 0 to 10 volts. Okay, was my voltage. And so halfway of that was like 5,000, right? Because when we're doing percentage, halfway would be 5 volts, which would be right in the middle, which was almost 0. Okay, and so we end up getting a little table form here. Maybe I should open up a spreadsheet and put it in a table for you guys. Let's try Excel here. Since I might make more sense if I try to do it in something like Excel. All right, so all right, so for current, okay, so channel 0 output. Okay, so channel 0 output is a 4 to 20 milliamp signal. And so when I output a percentage, when I output a percentage here, okay, I'm going to output a percentage of 0, which is going to output 4 milliamps. Okay. So my input, okay, for my input now, I can, on the input, we have choices. We can do raw. We can do, let's see, raw. We can do something called, they call engineering units. Or we can do a percentage. All right, and so if we do raw, again, the range for raw, is basically, I'm going to do it roughly here, minus 30,000. Okay, to plus 30,000. That's the range for raw. And so if I'm at 4 milliamps, but my input is actually doing 0 to 20 milliamps. And so my input there was my input was a minus 20,000. And then when it was 2,500, when the percentage was 2,500, it was outputting 8 milliamps. And when it was 5,000, it was outputting 12 milliamps. And when it is 100%, which is 10,000, okay, percentage, so this is actually percentage times 100. So when we output that, oh, well, wait, I'm sorry, let me do 7,500 here. 7,500 would be 16 milliamps. And then 10,000 would be 20 milliamps. Okay, so this is what I'm outputting. So when we do that, we had 20,000 here, and this was 30,000. Okay, so halfway would be right around 0. And 8 milliamps would be probably about 10,000 or minus 10,000. Or no, wait, I'm sorry. Let's see, 1/4 of the way. Right, this is 2,500 or 1/4 of the way. So for 1/4 of the way, this value should probably be about minus 15. And then this value here should be about 15. So when you look over here, so I've got this over here so we can see these numbers. So we're getting close to 10,000 over here. So when we get close to 10,000, there, we're going to see it's going to be about 30,000. Okay, may vary a little bit, but you know, we've got a little ways to go. Now, if I was to switch to engineering units, this would actually be microamps. Okay, this would actually be in microamps. And so what would happen is this would actually be 4,000 microamps. And I'll do that in a little bit. 4,000 microamps. And then this would be 8,000 microamps. And this one would be 12,000 microamps. And this would be 15,000, I'm sorry, 16,000 microamps and 20,000 microamps. Okay, because technically it's milliamps, but they scale it to give us some resolution. So they call it engineering, and it's a 4 to 20, but it's actually microamps. And then the percentage would be 0%, 25%, which would be 2,500, 50%, which is 5,000, 750, not 70, 750, and then the 10,000. All right, so you can see here, we actually reset, the timer reset on us. Okay, so we're coming back up to about, 700. So you see the values there. Okay, so we're outputting about, 1,000 is kind of a small amount, but you see it's a minus 15,000. Okay. And the voltage is like the same thing, but the voltage is counting from 0. So now what I want to do here is just show you microamps. So see if I flip over here, and I'm going to change the input from milliamperes, from 0 to 20 milliamperes, into raw, into engineering units. Okay, so if I change this to engineering units, notice here is the value. So when I'm putting out 20%, okay, so I'm outputting about 20%, right? Well, 15% right now. I'm outputting 15%, and so we're at about 6,000. Okay, so remember, when I output 25%, it'll be at 8,000. And so you can see we're looking at this number right here. So when this number is 25%, this number will be 8,000 microamperes. Okay. And so let me get to the right window. Sorry. All right. So when we look at that, that's what it's doing over here. Okay. And so we're at a little over 7,000 now, and we're at 2,000. So we're putting out 2,000, which is 20%. Okay, and we're bringing that in. We're bringing that in engineering units, and so it's at about 7,000 milliamperes. Okay. Now it's getting really close here. Okay, as we look over here, it's getting really close to 2,500. So when this is 2,500, we should see that this is 8,000. Okay, so you see that that is 8,000 over here now. All right, and if I flip back over here to raw, okay, we see that it's minus 6,000. Okay, so the raw This is probably more like about 10,000 here. It's probably more about 8,000. Okay, minus 8,000. Okay. I'd have to calculate it to see exactly what this value here is. But so what we're doing is we can select percentage values, or we can select raw numbers. And so remember, raw numbers is going to go from about minus 30,000 to plus 30,000 because it's a 16-bit number, but that most significant bit is that sign bit we talked about. And that's why it runs that way. So raw is running from about minus 30,000. Technically, it's minus 32,768 to plus 32,767. Okay. And then these engineering units. All right. So when we configure this, okay. So the big thing is when we configure this, we have to come in here and we have to actually enable these things. See, if I disable this and I come back in here, okay, I don't think I applied it or something. It's still moving, okay, but it, okay, so I didn't apply it. So, but if I applied it, you see that the input is no longer moving because I've disabled the input. Okay, so you must come into your input and you must configure it and enable it here. Okay, now the format option here, we can change this on the fly. We don't actually have to re-download. Okay, or I can enable and disable without re-downloading, right? I didn't re-download, I just went in and enabled or disabled. Okay. So we can do that right away, but you have to look at these scaling values. And so the next thing we'll actually talk about, and I'll try to do a lecture on Thursday evening and talk about scaling. Okay. And kind of show you some differences there. Okay. All right, so is there any other questions or anything? I'm looking at the chat window now, so you know, if you want a question there, or if not, I think I'll be done for this evening. Okay, but what I kind of tried to show you was, you know, how to come in and configure your modules, select your PLC, talked a little bit about the tags. Okay, and creating the tags, and you can set the values. So again, I came in here, so if I go offline, I can come in here to monitor tags and I can set values. Or when I'm online, okay, when you are online, you can come in here and set values like your timers. I can come over here and I can change these values. Okay, and now the accumulator value, you probably don't want to mess with that most of the time because the counters are automatically updating those. All right, so and timing bits and done bits and things like that, you probably don't want to change. But I could change the preset value. And so now, you know, you can see my preset value has changed. Okay, so we can change values of tags on the fly. However, if you change it on the fly when you go offline and then you re-download the program, it's going to reset back to what it was from the download program. So you want to, if you're going to set values, you really want to be offline and set them and then re-download those. Okay. All right, so notice here that this thing is already, I'm in engineering units now, I believe, on channel 0, so it's automatically outputting for, you know, at such a low number, we're getting 4,200 here because this is in engineering units. And we can double check that. right? So my input is in engineering units. And that's why it's at a little above 4,000 right now. Okay. So let me just come in here to my controller. Let's see. I'm gonna set my virtual stop back to a 0 to stop it. Okay. So now I set that to a 0, so my timers are not advancing. And I'm going to reset my counter accumulator to 0. So I'm just going to force it. Okay, you can also force them right in here. Okay, you can force values in here. So I set that to 0. And what I want to show you here is by setting that to 0, so it's outputting 4,000. And again, the reason for this is I set up the current output to output 4 milliamps if the value is 0. But I'm reading in 0 milliamps because your input is actually always reading in 0 milliamps. But if I went to the configuration, which I can do, I could tell it to only accept a 4 to 20 in, and that would actually force it to 0. Okay, now to do that though, I have to change my input alarms. Okay, otherwise it won't let me get away with that. Okay, better read the message here. 0 to 3200. So I have to have a minimum value of 30. Minimum value is 3200. That's because I'm in engineering units. Okay, I'm in engineering units, and I'm telling it it's not allowed to be below 4 milliamps. And remember, these are microamps, and so it's telling me that the lowest alarm value would be 32,000, which means if it's 3.2 milliamperes, it's going to yell at me. And then the high value should really be something like 20,000. Okay, because I'm in engineering units, and that's why I got to change that. All right, so I put that in there. Okay, and so I'm outputting 0 milliamps, and I'm getting 4 milliamps in. Did it actually apply? It looks like it applied. Okay, but when the 4 milliamps comes in, it's showing me 4,000, not 0. Okay, which it was doing here also. So anyhow, so you have these, in these settings, we have these different values, and we'll do a lab on this to work with this in the classroom also. All right, so that's all I'm going to do for tonight. I appreciate you guys logging in. I did record this, so I'll post it later so you can watch it.